Hi guys, this is a snip from worksheet number 8, which is going to help you practice some gas stoichiometry. Again, just like the video from yesterday. And the nice part is this strategy right here. And it says if you start with the mass of something or a volume of something at STP or particles like atoms or molecules or formula units, you're going to do regular stoichiometry to figure out how many moles of a gas you have that is not at standard temperature or pressure. So we can go that direction. Otherwise, we'll be given a gas that is not at standard temperature or pressure. Have to figure out how many moles of it we have based on the ideal gas law. And then we can use that amount of moles in a stoichiometry problem about another reactant or product. And so what I'll do is the first two problems as an example of going at it from the direction of on this side over to our gas, or from our gas over to something else. So if you look at problem number 1, we have 20 grams of calcium reacting with hydrochloric acid. We get hydrogen gas collected. What's the volume of the hydrogen gas? And very nicely provided for you here is a balanced chemical equation. So looking at what we're asked, what is the volume of the hydrogen gas? We're going to start with 20 grams of calcium. So we're over in the mass section right here. And then, so we're going to go from the left of this stoichiometry strategy to the right. So we're going to start, this is problem number 1. We're going to start with our 20 grams of calcium. And then we'll convert that to moles. So 1 mole of calcium is 40.08 grams of calcium. And then we can use the mole ratio from the balanced equation. So 1 mole of calcium. And then we're asked about the hydrogen gas. So that's a 1-to-1 ratio, 1 mole of hydrogen. And if we do that stoichiometry, we will find that we have 0.499 moles of hydrogen gas. That's going to become the N in RPV equals nRT. And so to figure out the volume will then be nRT over P. And I can plug in what I know. I know I have 0.499 moles of hydrogen gas. The volume or the pressure in this one is given to you in atmospheres, so I can use my 0.821 liter atmosphere mole Kelvin. Temperature, let's see, 350 Kelvin divided by our pressure of 2.5 atmospheres. And so the volume of our hydrogen gas will be 5.74 liters of hydrogen gas. And so that's our first approach. Problem number 2, I'll do in a different color so you know it's a different problem. Okay, problem number 2. What mass of potassium chlorate, notice that is not a gas, and so we're probably going to start over here on the right. So what mass of potassium chlorate reacts to produce 1.8 liters of oxygen gas at 315 Kelvin and 0.85 atmospheres? Again, you're given a balanced chemical equation. So now we are starting with a gas not at standard temperature and pressure. We can use the ideal gas law to determine how many moles of that gas we have. And so I'll solve for moles. N equals PV over RT. And so that pressure given to you in the problem is 0.85 atmospheres. The volume is 1.8 liters. R is 0.0821 liter atmosphere mole Kelvin. And the temperature is 315 Kelvin. And from that, you'll find out that you have 0.059 moles of oxygen gas. I can then do the stoichiometry, taking this 0.059 moles of oxygen. I can go right to the balanced equation for the mole ratio. So let's see, 3 moles of oxygen. And you're asked about the potassium chlorate. So 2 moles of KClO3. And we want to know 1 mass. So 1 mole of KClO3 is 122.55 grams of KClO3. And doing that, we should find that we have 4.82 grams of KClO3. So this shows you how to use this stoichiometry strategy from either direction. So your assignment for today is to do problems 3, 4, 5, and 6, and upload a picture of that to Canvas by midnight on Wednesday the 18th. Thanks, and please email me